whole pile of these pedals. Right? I bought them. And what it is a percussive tremolo. So instead of the LFO being a sinusoid or a ramp or a square wave, it's an exponential. Okay? So it gives this quick ramp up and then it's a decaying exponential, right? And then you can vary the rate. In this particular one, you can't vary the depth at all. That's fixed. You can vary the rate, and in this case, they put the rate in a expression in the expression pedal, so you can vary it by moving your foot. I think I have an example. Now this is just using just a simple tone, but that's the percussive tremolo with the simple tone. So you hear it's got a very different sound from other tremolo. Yeah.
Do you know how this is done? By like, is it like biasing instead of an LFO? You use like a capacitor.
What it's actually done? This is a good question. It was actually done on something called a unijunction transistor. And it was actually a specific type of transistor that was good for this kind of thing, and they're really not made very often. They're kind of one of these evolutionary dead ends. So, so if this thing dies on me, I don't know what I can do about it. But yeah, you could probably do it a couple different ways, and I've thought of ideas to do it, although I haven't come up with anything to do it yet. And that's it with noise. I have no idea what all these things are. Okay. Then this is the same thing run through a chain of events. So this is an envelope trigger based on it. And this was based on, again, a friend who plays trumpet actually played his trumpet through this into an envelope trigger into a delay. And we got some great sounds. And I've got I'm sorry I didn't record it because it was really great. Next time we've got to try and record it. Because playing one tone through it kind of doesn't sound very musical, but you can hear the fun stuff you can do. That's playing with the delay. Okay. Alright, so getting back to other, this actually probably should have been simpler, because this is probably the simplest effect. This is the boost or preamp. And I guess the reason I put this is because inherently this creates a linear, clean gain. But in reality, what you often use a boost for is to get a linear, clean gain and run it right into an amplifier so that you clip that first stage. Right? Because the first stage of an amplifier is expecting a guitar signal. And he wants to buffer that, he wants to boost it cleanly. But if you give it something that's now 10 times what a guitar signal is expected to be, you're going to saturate that first gain stage. And that was it still is a common way of getting more distortion out of an amplifier is to slam that first stage. It's also good for buffering, although this particular example doesn't buffer too well. This has actually got a very low impedance, so it's not a good buffer. Other design circuits have, mega ohm, 5 mega ohm impedance. There's some pedals out there that are really more designed for buffers. The Z-Vex makes a pedal called the Super Hard-On, which has a very high input impedance, Whereas this is low. So this is going to affect your tone. It's going to load your guitar more. The typical definition of a preamp is a wire with gain. Like the ideal preamp is you have no coloring, no frequency variation. In reality, you always get some, and many times that's good. This, like I said, this particular one is a simple inverting gain stage. There's no circuit board in this pattern. This is if you've seen electroharmonics, it's a good sized enclosure. There's no circuit board. The transistor is on the back of the pot, and there are a few resistors, and everything just hangs off the pot. The rest of it is all air. Okay, then I get back to it, the oscillating type of effects. I'm going to talk about ring modulating. Now, if you look at the theoretical design here, it looks exactly like the tremolo, right? You've got an input, you've got a, what would be the LFO or the tremolo, and then you've got an output. So the difference, theoretically, between a tremolo and a ring modulator is the LFO is replaced with an audible frequency. Okay? And so what happens when you multiply two frequencies? What do you get at? The sum and difference, right? So what's the problem with that in this particular case? Typically you put in one fixed frequency and then you play a bunch of notes against it. The sum and difference aren't musical. They are whatever they are. And it can sound very harsh, and it's probably one of the least used effects because of that. So, for example, what I've done on the left here, I picked I played a major scale. That's what so this is a spectrogram of the input of the major scale. So you can see, whole, half, whole, half. And then I played it with a fixed 400 hertz frequency. So you're coming out, you hear the sum and the difference. And then here's, the difference is like sub-audible here. And then the speakers don't reproduce it. What's interesting is that, this, as the tone goes up, since it's fixed, the sum goes up, the difference goes down. At some point, the difference actually hits a minimum, and it looks like it's coming back up. That's because the difference has become a negative frequency, right? So you're seeing the negative frequency flipped around the axis. So that is a simple example of it. Here is a musical example. This is a song called Jellyfish Blues by Buffalo Dog. I'd asked some of my online friends for good examples of a ring modulator. One example that I found, that I heard was a ring modulator, but I wasn't sure, was Paranoid by Black Sabbath. And what I finally figured out, driving to work one day, is that it is a ring modulator on the right side. The left side is just a straight guitar signal. So it's kind of an interesting use of parallel effects, where if you did all ring mod, it would sound horrible. But by blending it that way, you can hear some of that harshness, but still keep some of the prettiness. Okay, so this is the analysis of a ring mod, right? If you multiply two things together, you get at the sum and the difference frequency. So there's our math for it. And then the reason why it's called a ring modulator is because usually you use this circuit, which has a ring of diodes. Like, it's just like a, what do you call it? A full wave rectifier. It uses that bridge. Well, that uses a ring for multiplication. That's also used in RF to do up and down conversion. That's a common circuit. Okay. It's just after 9. We will stop here before we get to the compressor, and we'll do some demos real quick. Because I don't want to bring the same pedals in again next week. Things still going. All right. So we'll demo some pedals before we cover them, but that's fine. All right. So first one will be the volume, which is get on the floor to make it work. All right, so simple. problem with passive volume pedals.